box plots box? Whisker plots. Is it lesson 1-4? Or it must be.
Give me 3 if we're going in order.
Well, 3 was creating a user
Oh,
history.
I mean, yeah, 4. If we're going in order.
Yeah, there it is, box plots. So let's make sure that we hit the vocabulary, okay?
Okay.
So a box and whisker plot. If I put a box and whisker plot up here, I'm just gonna do an arbitrary one. Or maybe we should make one. We could probably squeeze this down if we just made one from that data that starts out with a number 29 in the book. So I think we're okay with knowing what box and whisker plots describe, yes? Yeah, let's just do that. That would be a more efficient use of our time. So this one right here, those are Emmy awards, right? Oscars? Are those called the Emmys? Or is that different? Oscars? I don't know. So those are awards. The Metal Man. And so we're looking at example 1, the guided example 1. And I'm going to use that data to make a box plot, define what the 5-number summary is, and then to visit this idea of the minimum and the max and what the different quartiles are and where they are. So we can just squeeze all of that in. So I'm going to write the data up here so we have it. 29, can you read them to me? 36?
37, 38, 40, 43, 45, 46,
Oops. Yep.
47, 50.
Okay. So this is ages. Ages of the best actor Oscar winners from 97 to 2006. So we want to arrange these into a box and whisker plot. And if we make a box and whisker plot, remember it's going to look like this. And that's going to be our minimum, that's going to be our maximum. This is going to be the median of the whole data set. And each whisker and each half of a box will contain 25% of the data points. About. You know, if it divides up nice and evenly. This one isn't perfect, or I don't know, 1, 2, 3, 4, 5, 6, 7, 8. We have 10 pieces. So in theory, we'd have 2.5, 2.5, 2.5, and 2.5, and we won't. But in theory, that's 25, 25, 25, and 25%. So if we're going to make a box plot, first thing we should do is look at our minimum and our maximum, draw a number line to contain those. So I'm going to come down here. And I'm going to say, let's see, that this is going to be 30. So that's 29. 1, 2, 3, 4, 35. 6, 7, 8, 9, 40. 45. 50. So we don't need all of that. We don't need all of this. So this is going to be our scale that we're going to build our box plot on top of. So let's come in and make a blue box plot. And the way we should do this, I think the easiest thing to do is start with the smallest value and put a dot there. That is said to be the minimum. Right there. Then we'll go to the largest value, we'll put a dot out here, which is said to be the maximum. And then, if we cross them off and we find, I'd like to go to the median. I think that that's the easiest. So we cross them off, there's 5 on the small end, 5 on the big end. So you have 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So halfway between 40 and 43.
41 and a half.
41 and a half. That's the median. And I'm going to label that as such, 41.5, so I know that the number's there and I remember it. Now we're going to take these, this is the lower half, and we're going to divide that in half. We're going to find the median of that. So the median of that is going to be half of 37. So that's the bottom end of our box. Here's the left side of our box. And then we're going to put a whisker. And now we have to do the right side of the box, which is gonna come from these points. So 46 is the median of the upper half. And we're gonna put a whisker on it. So there's your box and whisker plot. This will be the median. Then what we do is we say, we move from here to here. This is quartile 1, or Q1. This is Q2, quartile 2. And this is quartile 3, Q3. Now, the 5-number summary just have an eraser on my wrist. So the 5-number summary is the minimum Q1, Q2, Q3, and the max. So that's going to be 29, what do we say, 37, 41 and a half, and then we have 46, and 50. That's the 5-number summary. It's just a shorthand for writing down what all the values are without having to make a box and whisker plot. So far, so good? Straightforward? It's like real elementary. We've seen a fair amount of it already, just now we're naming it a little bit differently. Okay, then, in working with this and taking a look at the spread, you may recall in the past we've said, oh, sometimes there's an outlier and it's not a part of the box and whisker plot, and it's just this dot, this piece of data that doesn't fit the rest of the data. So by definition, we have to figure out what an outlier is. And statistically, by definition, an outlier is something that lies further from the first and the third quartile than the range of the first to the third quartile times 1.5. So let's write it. Interquartile range. So interquartile range means between the quartiles. You know, like so it's going to involve more than one quartile. So that would be this distance. It's the distance from here to here, the number of units, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And we find that by taking this Q3 value, subtract Q1. So it's just the difference between those two numbers. And that's how we find distance. And if we just make sure we take the bigger number, subtract the smaller, we don't have to deal with absolute value. We just, how far is it from there to there? So in this case here, in our example, it ends up being 46 subtract 37, which is equal to 9. So that's the definition of the interquartile range. Now, the definition of the outlier is this range made 1.5 times as big, and then we measure from this end out, and we measure from this end out. And we see if there are any points that are beyond that. So we take 1.5 of this width and measure from this point forward and from Q1 back. So, and it might be easier just to say how we calculate an outlier. So an outlier will be if we take Q3 and we add 1.5 times the interquartile range. So let's just do it and see how that looks picture-wise. So in this case here, our Q3 is 46. So that's 46. And then we're going to add to it 1.5 times the interquartile range, that spread, which is 9. So 1.5 times 9 is 13.5. So that'd be 59.5. So what we do is we look out here and we find 59.5. And we look up and we say, are there any data points anywhere from here beyond? And they aren't. So all the data stays within this 1.5 of these boxes spread. So we're okay. So let's look the other direction. So the second way to find an outlier is to take Q1 and then go backwards. So we're going to subtract 1.5 of the IQR. So then that ends up being 37. And then this we said was 13.5, right?
Mm-hmm. Subtract.
Oh yeah, what am I doing? And that's going to be how much?
23.5.
23.5. Sorry, I gotta let something rattle around in my brain, okay?
Okay.
Okay, good. So now I look back down here to 23.5, and I say, all of the data fits within. So we're okay. Now, if this had a data point that came down to 22, which wouldn't have changed anything other than this big long whisker, if that would have been the case, then we would have cut that off, made it a dot outlier, and then slid the whisker back to the next value. And that's all we would do for adjustment. We wouldn't change anything beyond that. So in this case here, we have no outliers.
Right.
Where are you at with that?
I get it. I'm trying to conceptualize, like, it seems like another way to find an outlier is take the interquartile range, multiply it by 2, and go in either direction. Oh, no.
Like go either direction from the median?
5. That's what it is.
Yeah, we can't do that. It's 1.5.
1.5.
Yeah, so you have to reach from the end of the box 1.5 times the length of the box. Then you reach from the other end of the box back. I don't know that there's another way to write it. At least I haven't ever seen it. I haven't thought about that. I think I goofed up with the twins yesterday. I think I subtracted 13.5 from 46. That's what was going around in my head. Because then I'd have gotten 32.5, right? Yeah, that's what I did. So I screwed up. I bet when they're doing their homework, they're going to figure that all out. I should probably email them, send them a message and say, I goofed up on the IQR on the left side of the box and Whisker Plot. Like, I swear it was this one. That's when I stopped and started doing the numbers in my head real quick. Yeah. Okay. So here's a comparison of box plots and histograms. You know, they kind of show a lot of similarities, but what the box plot does is very quickly, break things up into quarters. And it shows us the median real quickly. So it shows a little bit more information. So we've got histograms, and we got box plots. So if you looked at histogram A, where do you think that median is going to fall?
Somewhere in the lower part of the tallest pillar.
Yeah, because a histogram's a frequency distribution. So, yeah, it's got to be in the middle. So if you look at that, it looks like there's something real far to the right, so far away. Otherwise, it's packed pretty close together, isn't it? So which of these would it make sense to match up with?
box plot too.
Yeah, there's your outlier here. Whoops. Wonder what we're gonna get. Okay, good. Yeah, so here's your outlier right here, and then here's all the data squeezed in, data squeezed in. In fact, these are even considered to be outliers because there's so much clumping into those first couple of bars there. Okay, so which was that one gonna match up with?
Box plot 3.
3, yeah. A lot of data spread out and tailed off. 25% of the data is spread out and tailed off like that. And then the far right end, everything's squeezed tight together. And this is pretty normal. A more uniform, almost symmetric looking box plot. So there. I think that's enough to get you going. Should work.